Hello friends, welcome back. Welcome to Pebbles SSC Mathematics. We are learning Geometry Chapter 1 Similarity. Now today we are going to learn three properties. Rather two properties and one theorem. The first property we are going to learn is similarity in right angled triangle. Okay. Now what this property is? Suppose ABC is a right angled triangle and from one vertex if we draw a perpendicular on the hypotenuse which meets at point D, then the triangles on both the sides of the perpendicular are similar to each other and they are similar to main triangle. This is the property. I told you the similarity chapter is very simple. There are so many properties and theorems and those are extremely easy. But again and again I am telling you, in case of the similarity chapter, that is, you have to be very careful while writing the names of the triangle. Okay, though this property is very simple, that is a similarity in right angled triangle, we have to take care about writing the names. Okay, that means first of all we are taking the ADB, the triangle which is on the left hand side of that particular perpendicular, and ABC, that is the main triangle. Now you know that the names of the triangle can be written in any way. That means if you say that this is triangle ABC, then triangle BCA or BAC are one and the same triangles. But when you are comparing those triangles, when you are telling that this triangle is similar to some other triangle, in that case whatever points, whatever vertex you are writing must be also similar to each other, must be also same in both the figures. For example, here I am starting with the A, then D is the perpendicular or right angle which is I am taking at center, and then B. So here also I must start with A, then right angle in the center, and then C. You cannot write ADB is similar to ACB. You cannot write that. Why? Because C is not a right angle. Then these two triangles will not be similar triangles. See, practically both are the same triangles. But why you should not write like this? Because whenever you want to take the ratios, we simply take the first letter, second letter upon first letter, second letter. If you write this name of the triangle in different way, then what you will write? AD upon, suppose this is BCA, then BC. But AD upon BC, this ratio is not right. So you have to take care in this chapter about writing the names of the similar triangle. Okay, and this is very tricky. Many students fail at this. That means if the triangle is something very complicated, in that case the students fail to write the perfect similar triangle names. Okay, so here I am starting with, for this smaller triangle and this bigger triangle, starting with A, then the right angle at the center, and then B. Okay, so ADB. Now here also I am starting with the common point A, then right angle at the center, that is B, and then C. Similarly, BDC, that is the triangle which is on the right hand side of that particular perpendicular. So I am talking BDC. Again D is at the center, so again ABC I have to take. AB, B at the center, ABC. Now why you cannot take CBA? Because you will say that again the B is at the center, then why not CBA? Because can you see that this is a hypotenuse? Just check from where you are starting. Okay, this is the acute angle which comes at the last, and that is why I have taken that on the last. Or you can say both are the common point. This is the common point, and common point must lie on the same position. That means here if the common point is third, here also the common point is third. Now let us consider about these two triangles, first triangle and second triangle. ADB, A, D at the center and then B, and here also B, D and C. Now you will say that B is the common, but actually these two triangles are totally different triangles. So there is no point in taking this B as a common point, because that is not actually a common point. Both the triangles are separate triangles. So only this thing you have to know. Otherwise, the similarity in right angle triangle is very simple, that if you draw a perpendicular to the hypotenuse from opposite vertex, then the triangles on the both the side of the perpendicular are similar to each other, as well as they are similar to main triangle. Okay, let us see another property, that is the property of geometric mean. Let us see what you mean by the geometric mean. Now suppose this is a right angle triangle PQR, and now again there is a perpendicular to the hypotenuse which meets at point S. This is a right angle again. Then the property states that this length of SQ is the geometric mean of the two segments combining which your hypotenuse is formed. That means this hypotenuse PR is now divided into two parts. One is the PS and then is the SR. So we can say that SQ square is equal to PS into SR, which is the geometric mean, and hence we can say that SQ is equal to under root of PS into SR. This is called as the property of geometric means. Both the properties are very easy. Rather, this similarity in the right angle triangle you can use for proofs in Pythagoras theorem. Okay, so now let us see the Pythagoras theorem, which is the theorem in this topic, and then we'll solve few examples, and then we'll go to 1.5, exercise 1.5. Now let us learn what is the Pythagoras theorem. Now Pythagoras is generally called as mathematician in your mathematics books, right from the 5th, 6th, 7th, 8th, 9th standard, 10th standard. It is called as he is called as the mathematician. If you are interested in the ancient civilizations, and if you have read the books on the ancient civilizations, or in the recent era, it is proved or it is evidence that the Greek mathematician Pythagoras, what they call, was not a mathematician, because he has invented or he has stated nothing but the Pythagoras theorem. Okay, so the new postulate, the Pythagoras was actually a traveler, was a collector. Okay, he used to travel and collect the things, because before Pythagoras, the Babylonian, then the Chinese, Egyptians, and of course before all of them, Indians knew this theorem very well, and they were using it in their constructions, in their yagyas and everywhere. So I personally, suppose in your book it is given he is a mathematician, so you must call him as a mathematician, but I personally don't call him as a mathematician, because whatever the theorem or whatever the triplets he gave were well known to us well before Pythagoras. So let us not go into details of it, or let us not generate any arguments or any chaos about it. Let us go to the theorem, which is called as a Pythagoras theorem. Theorem is extremely simple, and you must have studied this in your 7th, 8th and 9th standard also. Okay, so the theorem says that suppose this is a right angle triangle. Now let me tell you one more thing. In many videos on the YouTube or in many books, it is given that the Pythagoras theorem is square of the hypotenuse is equal to square of the height plus square of the base, but I personally will not call it as a height and base. Okay, I will call it as a addition of squares of the two other sides. Why? Because here when the triangle is like this, you will call this as a height and this is a base. But suppose I turn the triangle 90 degrees, then what you will do? Then this height will become base and this base will become height. Actually, when you want to find out the hypotenuse or any other side, nothing wrong is there. Okay, but suppose in case of some other kind of problems where you have to find a height and base, in that case it can be a problem. Okay, that means wrongly you can say that this is base and this is height, or this is height and this is base. Okay, so better than that, we will call this as a hypotenuse square is equal to the addition of the squares of the two remaining sides of a right angle triangle. For example, and it is just a convention, the side which is exactly opposite to your A is called as the small a, this is called as the C, and this is called as the B. Generally I call it. Okay, so Pythagoras theorem is very simple. B square is equal to A square plus C square, or you can say that AC square is equal to AB square plus BC square. This is the Pythagoras theorem. This is Pythagoras theorem. So now we'll see a few examples based on those two properties and Pythagoras theorem. Again, I am not going to show you the proof because I told you the reason. Your theorems must be exactly word to word same as your book. Okay, it must be same as your book. You have to by heart, rather I will not say don't by heart, you write down 3-4 times, you will understand it and you will easily remember it. So let us take few examples on this topic, that is two properties and Pythagoras theorem, and then we'll move to 1.5. Now examples based on these two properties or the Pythagoras theorem are very simple. You will be given right angle triangle in any form. Maybe there is one quadrilateral and two hypotenuse are cutting each other in the right angle, or there will be some right angle in the figure. Okay, so you have to use the Pythagoras theorem and you have to find out something. That means in triangle 3 sides are there, you will be given 2 sides and asked to find a remaining side. Okay, so in the right angle triangle ABC, B is 90 degrees. If AB is 5 centimeter, BC is 12 centimeter, then find the AC. Extremely simple example. Don't even think that such kind of examples will come in your exam. Even if it comes, just to check your arithmetics, maybe for the 1 mark only. So very simple. Sides of triangles are given below. Determine which of them are right angle triangles. In case of right angle triangle, write the length of its hypotenuse. Now we have seen two properties and Pythagoras theorem. But the converse of the Pythagoras theorem is also true. That means we say that whenever there is a right angle triangle, the hypotenuse square is equal to addition of other squares of the other two sides. So that is the Pythagoras theorem when they give that this is a right angle triangle. But suppose it is not given that this is a right angle triangle. But if you find such triplets, if you find that the square of the one side is equal to the addition of the squares of the two remaining sides, then it must be a right angle triangle. So the converse is also true. So the examples can be there on the converse also. Just like this example, they are given that 5, 8 and 10. 5, 8 and 10 are the sides of the triangle. Determine if this is a right angle triangle or not. So let us square the sides. So it is 25, 64 and 100. So you can see that this is 89 and 100. So it is not a right angle triangle. Another thing they are given 7, 24 and 25. Another triplet is given 7, 24 and 25, that is 49, 576 and 625. And you can easily say that addition of these two is equal to this. So this forms a right angle triangle. So these kind of questions may arise in this, and then you can find out the length of the hypotenuse. Now in this case, suppose such problem comes, then what you have to do? You have to draw a rough triangle and show that which side is the hypotenuse. So here 25 is the hypotenuse and 7 and 24 you can write like this. Okay. So examples are very simple, even on the converse of the Pythagoras theorem. Just in this case, don't forget to write the units. Okay, I have not written units anywhere. Actually, it is given in the book that units are centimeters. I have not written it, but whenever you are solving any problem, don't forget the units, because units are very important. If you don't write the unit, if the unit is given in the question and you don't write in the answer, then half of the mark is cut. If I am there as an examiner, I will cut your 1 mark. Okay, so if the question is of 1 mark, I will cut 1 mark and you will get 0. Okay, so units are very important. Let us go ahead. The problem is something like this. If the sides of a square are 8 centimeters, that is all sides are 8 centimeters, find the length of hypotenuse. Extremely simple. I will not even solve this, because hypotenuse, you know, square, all right angles. So 8 square plus 8 square, add them, take under root, and you will get the length of hypotenuse. Simple problem. Let us go ahead. The next problem is, the triangle is given ABC, and from A there is a perpendicular on side BC, that is D. They ask that, prove that AB square plus CD square is equal to BD square plus AC square. Now actually this problem is totally meaningless. Okay, they have drawn some triangles and they have taken any side and asking you to prove something. It has got no meaning actually. So when it has got no meaning, there is always problem. How shall I solve this? So in such kind of problems, if you have checked my other chapters, there also I have specifically told you that always see what you know about this figure. Now what I know about this figure and what properties I can apply there. First of all, I know that this is a right angle, so I have got 2 right angle triangles, and as soon as I got right angle triangles, I know the Pythagoras theorem. Okay, and here I can see AB square. So AB square is equal to BD square plus AD square. Okay, AB square is equal to BD square plus AD square. And if I am taking this right angle triangle, I also know that this is also right angle triangle. I can say that AC square again is equal to AD square plus DC square. AD square plus DC square. Now can you see any similarity in that? Yes, AD square is there on in both the expressions or both the equations. So what I'll do, I'll simply subtract. So I will get AB square minus AC square is equal to BD square plus AD square minus AD square minus DC square. AD square I will cut, and now here it is positive, so I'll get that DC on left hand side, so I'll get AB square minus CD square is equal to BD square, it is plus AC square. When minus CD DC comes to this side, it will become plus, and so it is proved. So in case of such meaningless problems, what you should do? You should examine the figure, first understand what you know about this figure and which properties or laws you can apply. If you get confused, straight away apply the laws, write the expressions, you will find the answer. You will come to know what to do after that. Okay, this is the general trick, because in the future chapters, that is second, third, fourth, 5, 6 chapters also, many such problems are there. Actually whatever they are asking to prove has got no meaning, but still the problems are there. Okay, let us see a few more problems. The next problem is the triangle PQR is an isosceles triangle with segment PR is equal to QR. Segment PR is equal to segment QR is an isosceles triangle. It does not looks like isosceles, but just consider this is the isosceles triangle. Okay, if PQ square is equal to 2PR square, PQ square is equal to 2PR square, this PQ square is equal to 2PR square, then prove that triangle PQR is a right angle triangle. Again one meaningless problem. Okay, now this is very simple. Since QR and PR are the same, and so 2PR square I can even write like QR square plus PR square. So PQ is a hypotenuse. Since PQ is the hypotenuse and QR square, that hypotenuse square is equal to addition of the squares of the sides, by converse of Pythagoras theorem, triangle PQR is a right angle triangle. So please pause your video and write down this neatly. Okay, because we are just discussing, I am just telling you the solution, I am just telling you how to solve, how to write, but at last you have to write at least once. So please pause your video and just solve this. Once again there is a tricky problem. They are given one triangle ABC, and then on this height and this base from the opposite vertex there are the median. That means CM is the median of AB and AN is the median of BC. So we know that this side is equal to this side, these segments are same and these two segments are same, and B is a right angle, and they are asked to prove that 4AN square plus CM square is equal to 5AC square. Now again they are asking anything to prove. Okay, and the students get confused. Now where should I start? Okay, how to solve such problems? So I told you the simple trick. First of all, neglect what you want to prove and just concentrate on the figure. From figure, what information you get? The information you get that this is a right angle, 90 degrees, B. So we have three triangles now. One is the ABC bigger triangle, one is the ABN second triangle, and CMB is also right angle triangles. So now you have got three right angle triangles, and whatever they are asked, let us see. AN, now in this right angle triangle, this AN is a hypotenuse, CM is again a hypotenuse, and AC is again a hypotenuse, and the squares are there. So I have to simply use the Pythagoras theorem. So let us use the Pythagoras theorem in all three triangles and we'll get the answer. Let us see that. First of all, I'll say AC square is equal to AB square plus BC square. Okay, now here AN is again hypotenuse, so AN square is equal to AB square plus BN square. But whatever they are asked to prove, is there anywhere BN? No. Three hypotenuse are there. BN is not there. That means in between this segment is not taken. So what I will do? Instead of BN, can I write the half of the BC? So I will write that AN square is equal to AB square plus BC square upon 4. Upon 4 why I have taken? Because BN is the half of BC. So that 1 upon 2 will also get square. So what I get here? 4AN square is equal to 4ab square plus bc square. This is the first equation I got. Now many students will say in comments that we have not understood this, how this expression comes. Okay, this is what I am telling you, you should know the arithmetics properly. What I did, first of all, cross multiplication. So 4ab square plus bc square upon 4. Now that denominator 4 will go here, so it will become 4an square. So 4an square is equal to 4ab square plus bc square. Now we'll take, now here you have to write in right angle triangle A and B. I have not written it here, but you have to write that. In right angle triangle A and B, as per the Pythagoras theorem, this is the statement, and then draw that. Now what will be the second step? In right angle triangle CMB, we have CM square is equal to MB square plus BC square. But again, this MB, can I write half of the AB? Simply. So CM square is equal to AB square by 4 plus BC square. So here also I'll get 4 CM square is equal to AB square plus 4 BC square. The second statement I got. Okay. What we want here? an square plus cm square. So an square and cm square. So we will add 1 and 2. Okay. When you add this side, 4an square plus 4cm square, 4 is common, will go out of the 4 will go out of our bracket. What will be equal to? 4ab square plus ab square is 5ab square, and bc square plus 4bc square is 5bc square. So can I take 5 outside the bracket and I will simply write ab square plus bc square? Simple. Now left hand side we got perfect. What about the right hand side? Here we have 5ac square, but can you see that ab square plus bc square? In the bigger triangle, ab square plus bc square is nothing but ac square. So I can write equal to 5ac square. It is proved. So what I did here, I simply neglected this first. I concentrated on the figure and I saw there are 3 right angled triangles. So I got 3 hypotenuse. I can easily apply the Pythagoras theorem because AN, CM and AC, all 3 are hypotenuse. So I wrote down the 3 statements and then observed it and added it. Very simple. Okay, let's go ahead. Now let us see one more example. The example is, there is one rhombus with the sides 10 and one of the diagonals 16. Find a second diagonal. Now to solve this example, if the figure is not given, of course, first of all you should know what is the rhombus. Then you should know what is the property of the rhombus. Only then you will be able to solve this problem. Now rhombus, I hope all of you know. The rhombus is nothing but a quadrilateral with all sides equal but no angle, right angle. So rhombus is something like this. Now these are 2 diagonals of the rhombus. Now sides they are given 10. Sides of the rhombus are 10 and one of the diagonal is 16. So let us name this ABCD, ABCD, and this is, let's say, P. The property of rhombus, you should know that the 2 diagonals of the rhombus are perpendicular bisector of each other. That means this is perpendicular, this is also perpendicular, this side equal to this side and this side equal to this side. This you should know perfectly, otherwise you will not be able to solve this problem. So let us consider that one of the diagonal, that is BD, is equal to 16 centimeter. Now can you find out the second diagonal AC? It is very, very easy. BD is 16. If BD is 16, then BP and PD must be same, half of them. So this must be 8 and this is also 8. Now since both the diagonals are perpendicular bisectors of each other, can you see that BPC is a right angle triangle, hypotenuse is 10, one side is 8. Can't you find a second side by Pythagoras theorem? So find out the second side, and again this side equal to this side, and hence just double of this will be the second diagonal AC. So please pause your video here and quickly find out the value of second diagonal, that is AC. Please do it now. The value of second diagonal is 12 because this is 6. 10 square is equal to 8 square plus 6 square. So this is also 6. So diagonal AC is 12. If you have written the answer 12, the answer is wrong because it should be 12 centimeter. Okay, just don't forget to write the units. Don't let me remind you every time, or in this case I am reminding myself. Anyway, so friends, with this example we are finishing this topic, and now we are moving towards the exercise 1.5. Thank you very much.